Good morning, good morning. Sunshine, sunshine. Free your mind, free your mind. You got to free your mind. Ooh-wee. That's right. The question of the day is, can genes be patented? Can genes be patented? That's the question. So let's go over here to this article and see what's going on, see what they say. Give me 1 second. We want to know if genes can be patented. All right. This is coming through. This is coming from. Hold on, let me do something real quick. Had something in the background. All right, we should be back online. Hey, check this out. Right now, we in medicalplus.gov. That's the website. No, I say my bad. It's a medlineplus.gov. Medlineplus.gov/genetics/understanding testing, whatever. All right. So let me read what they're saying right quick. The question of the day is what? Can genes be patented? That's what I want to know. Can genes be patented? Why do I want to know that? Because there's been a rumor going around that when people start receiving these whatever things going on, this new technology, that violate my rights. Yeah, that right there. They say people gonna be able to patent this. And if they put it in you, and they patent it, it said that they own you if, right, it could change your DNA sequence. Well, nah, not actually. Nah. Not if it could change the DNA sequence. If they could put a DNA sequence inside of you, type shit. Anyway, it's gonna make more sense when I read it. What they're saying. We're trying to explain it in layman's terms, but listen to what they say. Forget what I say. But this is what they say. It's a gene is the exclusive rights to a specific sequence of DNA, right? A gene given by a government to the individual, organization, or corporation who claims, hold on, I'm trying to get my mic right, who claims to have first identified the gene, right? Let me read that again. It's a gene patent. It's the exclusive rights to specific sequence of DNA, a gene, given by a government to the individual, organization, or corporation who claims to have first identified the gene. It's a once granted a patent, the holder of the patent dictates how the gene can be used. In both commercial settings, such as clinical genetic testing, and in non-commercial settings, including gene research, for 20 years from the date of the patent. What it say? It say once granted a gene patent, the holder of the patent dictates how the gene can be used, right? In both commercial settings, such as clinical and genetic testing, and in commercial settings, including research, for 20 years from the date of the patent. Y'all hear this? So for 20 years, whoever had control over a patent, you remember how they got Henrietta Lacks genes and stuff like that? So they basically owned it type shit, is what it seemed like, for whatever. And was able to do whatever they wanted to do with it, and couldn't nobody else do nothing with it unless they was given permission, you know? That's research and all. Nobody held a right to it except for you for 20 whole years. Right? Now, let's get to some specifics. They say on June 13th, 2013, 13, in the case of the Association for Molecular Pathology versus Myriad Genetics Incorporated, is a case between Molecular Pathology versus Myriad Genetics Incorporated. The Supreme Court of the United States ruled that human genes cannot be patented in the U.S. because DNA is a product of nature. So they're telling you anything that's a product of nature cannot be patented. So basically, it can't be owned or controlled, so to speak. Right? Not as a monopoly. So us humans are born naturally. So automatically we fall under natural law. That's very key now to understand. So once something else get placed on top of what it already is, it becomes unnatural. It becomes altered at that point. Like if it's open space and I can go in any direction, but you tell me I can only go straight or to the left or to the right, that's violating my natural rights. You see what I'm saying? Even it's being altered. That's why it's been, because it's being altered. Especially like you put up walls or something like that. Well, I mean, if there's no walls or anything like that, it's just open space and you're just making me do something. You see what I'm saying? And then it get manipulated when you put boundaries and walls and stuff like that. So now you're keeping a person from being able to go into something that was already there, that was natural, so to speak. Not necessarily saying it's bad or whatever. I'm just trying to give you an example of how everything is altered since day one, right? But everything is initially nature. Not everything, but like us humans and things like that. Things that happen by natural accordance. Right? It's all nature. All right. So what it was saying now, it say on June 13, 2013, in the case of the Association of Molecular Pathology versus Myriad Genetics Incorporated, the Supreme Court of the United States ruled that the human genes cannot be patented in the U.S. because DNA is a product of nature. The court decided that because nothing new is created when discovering a gene, there is no intellectual property to protect. So patents cannot be granted. Prior to this ruling, more than 4,300 human genes were patented, right? See, prior to this ruling, more than 4,300 human genes were patented, okay? It said the Supreme Court decision invalidated those gene patents, making the genes accessible for research and for commercial genetic testing. Okay, so it said they're no longer patented. They're available for anybody to use for research or whatever the case. or whatever. But before then, it was 4,300 that was patented. So because of that case, it got undone. Okay, it said the Supreme Court's ruling did allow that the DNA manipulated in a lab is eligible, right? It said what? It said the Supreme Court's ruling did allow that DNA manipulated in a lab is eligible to be patented because DNA sequences altered by humans are not found in nature. This is where the problem starts, y'all. Okay, because you got people out here, they want to patent DNA. They want to create their own species of being by manipulating and rearranging the DNA. What they call genetics, what they call yeah, genetics basically. All right. So pay attention. All right, so the Supreme Court's ruling did allow that DNA manipulated in the lab is eligible to be patented because DNA sequences altered by humans are not found in nature. The court specifically mentioned the ability to patent a type of DNA known as complementary DNA, in parentheses, cDNA, lowercase c. It's this synthetic DNA, okay? It's a synthetic DNA, meaning fake. It's produced from the molecule that serves as the instructions for making proteins, in parentheses, called messenger RNA. Okay? So the messenger RNA is a synthetic form of DNA, basically. A molecule that helps synthesize DNA. All right, let me read that again. It says this synthetic DNA is produced from the molecule that serves as the instructions for making proteins, which is called messenger RNA. All right, so I think that's the main idea I wanted to get across to y'all. That yes, that if they are able to alter your DNA, they're saying they're giving you whatever, and they're supposed to go inside and rearrange some things and protect some things and organize some shit. I'm just saying, excuse my French, but you know how they're telling the straight up that's what they're doing, and that these things are gonna go in, they're gonna attach, and they're gonna make sure they protect you from any future complications or problems health wise, you know. And man, but yeah, I don't want to go too far into it. But if anybody thinking from a business mind frame, you can see you understand why these people are into this. But it's all about genetics and genomics, right? That's what it is. So the overall field is called genomics, right? And the specialized area of that field is genetics, right? And the main basis of genetics is dealing with genes. And when you're dealing with genes, you dealing with the DNA. And when you're dealing with the DNA, you're dealing with the makeup of a person. Or you're dealing with the makeup of a living being. And when you're dealing with the makeup of a living being, that could be anything, from an ant to a human. You know what I'm saying? Anything that's breathing, anything that has life, anything that grows, I suppose, actually, in actuality. Like plants and all these types of things, I would imagine that they have a DNA sequence, even though they may not tell us that. But I think everything has been made up of some type of DNA sequence. Uh, I don't know. That's just my thought on that part. I could be wrong. Maybe it's other thing with a spirit or flesh in it. You know what I mean? With a soul, so to speak, anything that can move and express itself. But not to go too metaphysical with none of this shit. But yeah, like that, like I said, the main thing I came on here to tell y'all about is that the fact that on June 13th, 2013, right, in the case of the Association for Molecular Pathology versus Myriad Genetics Incorporated, the Supreme Court of the United States ruled that human genes cannot be patented in the U.S. because DNA is a product of nature. So what I'm thinking, when you go patent our DNA, you need to claim ownership or make a living will or testament that can't nobody tamper with it or anything. You know what I'm saying? Because my DNA been given to me by my nature, and I don't have to allow nobody to tamper with it and change it and switch it. Right? Yeah, man. For real though. All right. So where we at with it? That's basically what I want to say about that part. Because what it say, what I was reading though, it was saying that the Supreme Court of the United States ruled that human genes cannot be patented in the U.S. because DNA is a product of nature. Why? Because it's a product of nature. Okay, the court decided that because nothing new is created when discovering a gene, right? Nothing new is created when discovering a gene. You see, that's just like when they say, "Hey, we discovered America," or the people say they discovered that. It was already here. Nothing new was created when what I'm saying, when you came over here for like the land goes. So you can't claim it, can't make it yours. You can't it can't patent it. You know what I mean? So I suppose. All right. So the court decided nothing new could discover the gene this property. Okay. So patents cannot be granted. It say prior to this ruling, more than 4,300 human genes were patented. Right. More than 4,300. That's a lot of your genes. And who to say what they've been doing and manipulating them to be since then? They were patented, bro. Meaning they own them. 4,300 human genes. Okay, I wonder how many genes are in it. Hold on. Let's see. How many genes are in a genetic makeup?
According to Medline Plus, genes tell the body how to build specific proteins. There are about 20,000 genes in each cell of the human body. Together, they make up the blueprint for the human body and how it works. A person's genetic makeup is called a genotype.
Y'all caught that? So about 20,000 genes in the cell makeup. And out of them 20,000, 4,300 of them, have been patented before this ruling of 2013. That was like right around the corner ago type shit. And y'all say you say that it's responsible for the genetic makeup, right? For humans. You know, it tell the body how to build specific proteins. That what genes do. What they do? They tell the body how to build specific proteins. Okay. And so they're coming up with a synthetic way of telling the genes how to build proteins. And once they do this, they can change your genetic makeup and it becomes theirs because it's not natural anymore because it's been altered by humans, right? So therefore, they can patent that because it's no longer natural. So if it's no longer natural, then it's synthetic. So therefore, they're trying to create synthetic human beings. Synthetic, censored. Syndicated. Yeah. Now, since proteins are so important, let's go ahead and run down how they made. So all this on the fly off the hip, y'all. I wasn't planning on going this far with it. All right. They say most genes contain the information needed to make functional molecules called proteins. Okay. What did it say again? It's the introduction. Most genes contain the information needed to make functional molecules called proteins. Now, mind y'all, molecules, they can't really get too much smaller than that. They don't really know how to get too much smaller than molecules and all that. Just so you know, okay? So then, like, it go too much. They can't even really see genes like that, to be honest with you. Not anyway, that's a whole other thing. We just keep it the books. You know what I mean? Let's stick to the books right quick and follow what they're saying. And then once you become more learned about it, you can discern between what's really what. You know what I mean? But I'm gonna give it to you raw though. 1K. So it said a few proteins produce regulatory molecules that help the cell assemble proteins. Okay. So you got a few genes that produce regulatory molecules, right? Certain molecules that help the cell assemble proteins, right? They help the cell assemble. So help them arrange it, help them put it together, help them organize it. It's a few a few molecules that do that. It's a few genes that creates certain molecules that does that. All right. Yeah. So it say during the process of transcription. Well, I didn't skip a whole bunch of stuff. My bad, y'all. It say the journey from gene to protein is complex and tightly controlled within each cell. Okay. Within each cell. It consists of two major steps: transcription and translation. Okay. Keyword: transcription. Another keyword: translation. Right? First you get transcript, then it get translated. All right, y'all? They say together, transcription and translation are known as gene expression. Okay? So however you transcript it and however it's translated determines the expression given by the gene. Okay? Which we have like 20,000 in each cell, they say. It say during the process of transcription, the information stored in a gene's DNA is passed to a similar molecule called RNA, right? Ribonucleic acid in the cell nucleus. Okay, so once everything is done, everything is, they say during the process of transcription, right, the information stored in a gene's DNA is passed to a similar molecule, called RNA, ribonucleic acid, or ribonucleic acid. That's what it say. In the cell nucleus. It's in the nucleus of the cell, right? The middle. Both RNA and DNA, which are duplicative of each other, are made up of a chain of building blocks called nucleotides. Okay, so the chain of these building blocks, right, which are RNA and DNA. So RNA and DNA are called building blocks, which proteins are building block called nucleotides, right? But they have slightly different chemical properties. So this chain has slightly different chemical properties on each chain. They say the type of RNA that contains the information for making a protein is called messenger RNA, or mRNA, because it carries the information or message from the DNA out of the nucleus, right, into the cytoplasm. Okay? So the DNA holds the message. The RNA come get it and run off with it, right? And distribute it to the cytoplasm. Take it out the nucleus. Okay? So say translation. The second step in getting from a gene to a protein, right, takes place in the cytoplasm. The mRNA interacts with a specialized complex called ribosome. Okay? So that's once it takes it to the cytoplasm, it interacts with a specialized complex called ribosome, which reads. Okay? That's what it do. It reads the sequence of the mRNA nucleotides. Each sequence of 3 nucleotides, called codon, usually codes for one particular amino acid. Okay? So each sequence of 3 nucleotides, okay, do 3 at a time. These sequences are different. They're called a codon when they're in a group like this. Usually codes for one particular amino acid, right? So you have 3 nucleotides in the sequence, and each one of these sequences forms one amino acid, okay? It's a amino acids are the building blocks of proteins. So once you put it into a block of an amino acid, then it becomes a protein, right? A type of RNA called transfer RNA, tRNA, assembles the protein, one amino acid at a time. Okay? So that's when it starts taking it out the nucleus and stuff like that, the RNA, before it runs it to the cytoplasm. It's a protein assembly continues until the ribosome encounters a stop codon, a sequence of 3 nucleotides that does not code for an amino acid. Okay, so protein assembly continues, right, until the ribosome encounters a stop. And that's a codon or a sequence of 3 nucleotides that does not code for an amino acid. So our system is kind of protected too. So if people get to tampering or whatever they're trying to do and don't come to a real sequence of the 3 nucleotides and in sequence how it's supposed to be, then our system will stop it. Okay. They say the flow of information from DNA to RNA to proteins is one of the fundamental principles of molecular biology, right? So it do go from the DNA to the RNA, and then within the cytoplasm, it does this other stuff within the cytoplasm, like it was just explained, right? It say the flow of information from DNA to RNA to proteins is one of the fundamental principles of molecular biology. So we're talking about molecular biology right now. It is so important that it is sometimes called the central dogma. Okay, it say it is so important that it is so. That it is sometimes called the central dogma. So you know how we say anyway. I don't want to go into all that, but yeah, keyword dogma, central dogma. That I mean the dogma of all dogmas. The you know the understanding of all understandings, the concept of all concepts, type thing. All right. That's a picture of how it looks. It look like a person almost with a head and all. That's crazy, right? Anyway, you keep going. I think that's it. Yeah, that was it. So that was a nice, quick, comprehensive understanding of what this RNA, DNA thing is all about. So let me go back right quick. So since we know how DNA work and all that, you understand what I was saying about that court ruling. Don't forget that was the main idea with a little bit of bonus to go in between, you know. But yeah, that's basically all I wanted to run down to y'all today, man. You know. So thank y'all for tuning in to another episode of the Wisdom Show. And yeah, until next time, I will get with y'all. Thanks for tuning in. Have a good one. Peace.